That's nothing but connecting the solar panels or modules in the both combination. Already we've seen how to connect to increase the voltage in series connection, how to increase the connect in parallel connection. So we are going to hybridize and we are going to connect them in series connection as well as in parallel connection. So this is called as connecting the modules in series connection and parallel connection. So why you are connecting? First question. So if you want to generate a solar power plant more than 100 watt peak, for example, I require 5 kilowatt peak, or if I require 10 kilowatt solar plant, definitely I have to connect the panels in series connection and parallel connection. Next one, this connection will help us to generate large amount of power in terms of, if you want to go in terms of megawatts, not in kilowatts. If you want to go in terms of megawatts, definitely we have to perform which combination? Series combination as well as parallel combination. Now I will try to draw the diagram for our understanding. Okay, let's try to take we have two solar panels. Okay, this is solar panel 1, this is solar panel 2. So I am giving the labeling 1, 2, and I have one more set of solar panel. Right, what are the terminals you are going to get here? This is one terminal, this is another terminal. So here what are you going to get? This is one terminal, this is another terminal, this is 1 and 2. So what is the name of this panel? 3, 4. So how to connect them? Now I am joining, this is I am taking this is positive terminal, this is positive terminal, this is positive terminal, this is positive terminal. Automatically this will be negative terminal. Now I will connect 1 and 2 in which connection? Series connection. If you want to connect them in series connection, how to connect them? Join the negative to the positive. When I join this negative to the positive, what will happen? So what is the rating of this solar panel? This is Vm and Im. What is the rating of this panel? Vm and Im. Now how we connected them? Series connection. When you connect them in series, what is the voltage you are going to get? This is nothing but Vm plus Vm. Already we had seen in series connection. You are going to get how much? 2 into Vm. And what is the amount of current? What is the amount of current in this branch? How much you are going to get? Im. Similarly, these two panels also I am going to connect in which connection? Series connection, and it delivers an output voltage of how much? 2 into Vm, and I am going to bring the terminals like this, and here I am going to join them. Here I am going to join them. Okay, you see here these are 3 and 4 are also connected in series connection, and what is the amount of current they are going to develop? Im current. Why? Because in a series connection current is constant. So here what is the total amount of current? Im. So this is the resultant terminals, you are going to get it here. So this is called as the maximum voltage of the array, and this current is called as the maximum current of the array. So to this node what you are going to apply? I want to find out the resultant current of the array. So how to find the resultant current? Already we discussed. Apply. Very good. Kirchhoff's current law at this node x, at the node x. So in this node x, what are the entering currents? You can see here Im is one entering current, and what is the next entering current? Im. So Im and Im are both entering, and what is the leaving current? IMA. What is IMA? The maximum current of the array. So array means if two or more group of solar panels is called array. Group of solar cell is called module. Group of solar modules is called solar. Just very simple logic, you already discussed this. Group of solar cells is called solar module. Group of solar modules is called solar panel. Group of solar panels is called solar array. Group of solar array is called as a solar PV system. Okay, this hierarchy already we discussed. So now Im plus Im is how much? 2 into Im is the maximum current of the array. So we got the current. Coming to the voltage. So what is the voltage you are going to have here? This is 2 Vm. So you can see here these two are connected in. So what is the voltage at this point? 2 into Vm, and what is the voltage at this point? Vm. What is the voltage at this point? 2 into Vm and 0. You can see here 2 Vm. This and this are connected at the same point. I can say in a parallel connection what is constant? Voltage is constant. Therefore, what is the maximum voltage of the array? Maximum voltage of the array is equal to how much? 2 into Vm. So this is 2 into Vm. But now we need to calculate the maximum power of the array. So now this is nothing but 1, 2 are connected in series, 3, 4 are also connected in series. But 1, 2, if the group of solar panels are connected, this I am going to call it as array 1, this I am going to call it as array 2. Now array 1 and array 2 are connected in parallel. Are you able to understand? 1, 2 are connected in series, 3, 4 are also connected in series. 1, 2 will constitute an array 1, 2, 3, 3, 4 will constitute an array 2. Array 1 and array 2 are connected in parallel. So now this is the combination of series combination and parallel combination. So we need to calculate the maximum current of the array. What is the maximum current of the array? Maximum current of the array is equal to maximum voltage of the array multiplied with the maximum current of the array. What is the maximum voltage of the array as per the problem? 2 into Vm. What is the maximum current of the array? 2 into Im. So when you multiply it, 2 into 2 is how much? 4. This is 4 into Vm into Im. So where I can write down 4 into Vm into Im is called as Pm. So the maximum power of the array is 4 times P maximum. How many panels we used? 4 panels. How many times the power is multiplied? 4 panels. If we use 6 panels, the power is enhanced how many times? If we use 8 panels, 8 times. So in such a way that your voltage and currents are going to increase. Here you can see here why it is 2 times Im. How many panels you connected? You are connected these panels to get 2 into Im. Why they are connected in series connection? Why you got 2 into Im? They are connected in parallel. So both are protected now. So series connection and parallel we are combining to get a total power of 4 into Im. So like this you can add 1, 2, 3 as one set. Next set is what? 3, 4. Next one 1, 2, 3, 4, 5, 6. Similarly or 1, 2, 3, 4, 5, 6, 7, 8. Like that you can add them in series connection and parallel. If you connect them in series, voltage is scaled. If you connect them in parallel, what is scaled? Current is scaled. So you can write down this in one more formula also. So if already a problem is given, we need to calculate the maximum power of the array is equal to maximum voltage of the array multiplied with the maximum current of the array. So what is the maximum voltage of the array? This is number of panels connected in series connection multiplied with Vm. This is Im is nothing but what? Im is nothing but what? It is nothing but number of panels connected in parallel multiplied with current. So this you can expand as number of panels in series connection, number of panels in parallel connection multiplied with Vm into Im. So this is nothing but Ns into Np into how much? Pm. For example, a problem is given to us, maximum power of the array. If n number of panels connected in series is 4, number of panels connected in parallel is 4, then what is the answer you are going to get? 4 into 4. How many panels are there? 6. Therefore the resultant power is how much? 16 pm. So you can see here 4 panels are in series and for that remaining 4 are in parallel. So the resultant you are going to get the 16 panels. Okay, so this is how to connect the panels in which connection? Series connection and parallel connection. Okay.